Everyone, my name is Zohra Shavlian and today I'm talking about project number 2. The project number 2 is done in two phases. One is using Dynamo to automate building parametric modeling, and two is applying Refinery as a multi-objective optimization node to find optimal solutions based on the desirable objectives. For the first phase, a simple panel with two instance variables is used. The variables are one, opening factor, which determines the opening of the shading, and two, width factor, which determines the width of the shading. So by changing this parameter, I can change the characteristic of my panel. Okay. The panels are then mapped on a cylinder using dividing surface tool. And then the location of these panels are then used using this Dynamo node to export the Excel files, the Excel file of the location of the panels actually. So the file is something like this that will be exported, and then it has been manually cleaned by very fast by using replace tool in Excel to remove all these text string from the file and get very simple numbers from the Excel file to then import it. Next step is to load the Excel file into a Revit project. So we open a blank Revit project, and this time we use the cleaned Excel file to import it in Dynamo. So this is the clean Excel file. We basically need the numbers as the coordinates of the points of the panels. And here we import the Excel file, we get rid of the commas and everything, and then we also have to load the panel that we want to use in the project level, and then we use this node to get access to that panel through Dynamo. And then with this node set parameter by name, we can actually have access to all the panels by calling their parameters. So the width factor and opening factor are those parameters that we want to change in this project based off of two objectives. One is the panel's angle due to the sun position, and the other is the panel's distance from the closest neighbor. Later in the last part of the project, the angles and distances are given as input variables for Refinery in order to get the maximize and minimize those objectives accordingly. For the first goal, the sun path is replicated using three variables of x, y, and z to define the sun vector. The ranges of the variables are exported from Revit for Boston sun path. These three variables are used as input variables later for Refinery. So by choosing each of them as input and select them as input, we choose them as the input variables for Refinery. Then the normal vectors of each panel is calculated through this normal as point to calculate the normal vectors from the midpoint of each panel, and then the dot product of the normal vectors and sun vector is calculated. The values are then remapped and given as the values for opening factor here. So we have 156 values based off of the 156 panels, and then these are given as the values to override actually the opening factor. And the same value is used for overriding the panel's color using this overriding color just for the view. And in this case, actually, through changing the position of the sun by changing these sliders, each time we get different opening factors and color for each panel. The next step is to get the values for shading width. As I mentioned before, I use a neighborhood block distance for the sake of this objective. So basically, a mass model is drawn in the project level as a neighborhood block. The bottom edge of this block, this model, is considered as the reference. So then the distance, as you see here, the distance of the midpoint of each panel and the closest point on the reference curve is calculated in Dynamo through these sets of nodes. To get the different distance values for refinery run, the location of the neighborhood block changed in respect to my cylinder project. So instead of moving the project and moving all the panels, I decided to move the neighborhood just because it was less complicated. These three variables actually are used to modify the location of the neighborhood block. Basically, rotation here is done through these three variables. One of them is the origin of the location, which is defined by x value and y value, and the other one is the degree or angle of the rotation. So for each location, I get sets of distances, sets of the distances as values, and these values, which are again 156 values for 156 panels, are then mapped and then given as the value of the new value of my width factor. So later, these three variables are chosen as, again, as input variables for refinery, and the sum of these distances are used as output for the other objective of my project for refinery. Okay, and the last part is refinery. So we just need to export our project for refinery, and you just export it, and then you launch the refinery. So I've already launched my refinery. So basically, when you open the refinery, you have to click on New Study, and then you choose your project, and here you see your variables that you choose for input and your objectives that you chose for output. Here you can choose which objective you want to minimize and which you want to maximize. I use 48 population size and 200 generation, and then just click generate and the refinery runs. So basically what refinery does is run a genetic algorithm to get those optimal solutions which meet your objectives, your defined objectives. So these are the solutions that I get from refinery, and basically I can choose either of its solution and open in Dynamo, and I can see the result in Dynamo. So I've already done it, and this is the result. So you see that the curve has moved, the distances are new distances, and the sun, actually this sun is not really my sun, so I just showed move it manually to see, but my sun is the one which has been controlled by these vectors. So I just manually moved it to show you that kind of the position of my sun will be somehow here, because these are red and these are green. And interestingly, the refinery, I don't know why it didn't show me the objective space. So I should have seen the values here as well, because I can see them in Dynamo. So here you see that those variables has changed. Those variables also has changed based on the solution that I chose, and these objectives also have some numbers. So basically refinery should give me this result here, so I can see the relationship between two objectives that I used here in the diagram as well. And yeah, that's it. I hope you enjoyed the video. Thank you.